Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is dynamic compaction for road construction. So, in this case study, we consider this Yamuna Expressway. So, in this project background, it is located in Uttar Pradesh, India, connected near Noida to Agra. So, this length approximately 165 kilometers. So, this proposed purpose to reduce travel time between Delhi and Agra, enhance connectivity and support economic development in the region. So here various challenges. The expressway cross areas with varying soil condition, including loose fields and soft compressible soils. So this is the soil background. So what we understand, Yamuna Expressway, one expressway we are going to propose. We are going to reduce the travel time between the Delhi and Agra, enhance the connectivity and support economic development in that particular region. In this, the challenge is involved in this ground soil condition because the express crosses areas with varying soil condition, including loose fields and soft compressible soils. So this is the challenge which we faced for this expressway. So what kind of technique we have to consider for this challenge? For getting the construction work is completed. For we require this Yamuna Expressway. So what are the techniques are involved? What kind of technique gives the better results? These are the things which we are going to discuss in this particular topic. Here, that based on the challenge, based on the type of the soil, here the type of soil is loose fields and soft compressible soils. These are the types of the soils involved throughout the in between, not throughout 165 kilometers. In between, this is the conditions which we are going to face in this particular challenge we are going to understand. This is the project background which we consider. Now, importance of this project, economic impact. So, facilitates trade and tourism, supporting the local economy. So, why they are doing this project? Because of these many challenges are there. So, it is difficult for us. So, how we are going to, why, what is the necessity means? So, because of the importance of the project, so once we are reducing the any travel time or we are going to developing in terms of roadways and tourism point of view, it gives the local economy is equal to improve its local economy. It affects the national interest also. It increases the national economy also. It affects the our development in terms of financial strength for these localities, and also it impacts the national economic growth also. Some sort how much it is, it will increase. So that helps for in economical point of view, and also these reduces the, and also one more important for this, it reduces the traffic and it reduces the how much train travel for from one place to another place. It gives the more interactions with the people. So, and it reduces so many parameters. It reduces the fuel and it reduces the effectiveness. So anyway, we are reducing this petrol and diesel means it is helpful for in another parameter also, and also the safety is there. Time is less time the people are traveled. They may be quality time they may use it in for other purposes. These are all involved in these particular things. So in this, safety improvement reduces traffic congestion on existing routes and provides faster and safe alternative. It is also reduces traffic congestion existing routes and provide faster and safer alternative. This strategic significance forms a part of larger infrastructure development plan connecting to the other major highways and economic zones. So this is the importance of this particular project. So here we are these facilities providing local economy, that is very very important, traffic conjunction, and existing routes their traffic is less and we are going to divert these traffic to another way, and it provides safety to the roads, and strategic significance forms a part of larger infrastructure development plan connecting to the other major highways and economic zones. So it gives them more appropriate in so many ways. So that is the importance of the project. So here we choose for this dynamic compaction technique for getting the desired properties for construction of this Yamuna Expressway. So here why? What is the dynamic compaction? So a ground improvement technique where the soil is densified by dropping a heavy weight repeatedly on the ground surface from a significant height. That is nothing but the dynamic compaction. We are compacting the soil using these heavy weights repeatedly onto the ground surface from significant height. Dropping these heavy weights, we will get the compaction. It means the objective of this dynamic compaction is to increase the density of loose granular soils, thereby improving their load bearing capacity and reducing the settlements under structural loads. So once we done this compaction, the whatever the way it is there, it is so many heavy vehicles are going to move in that locality, and they are going to bear all these. There is such kind of settlements already done using this technique. So we will get the improve there. What are the properties are going to affect because of these dynamic compaction. So here we understand technique. What we choose, that is equal to deep dynamic compaction. Finally, what are the outcomes we are expecting? Those are load bearing capacity, and settlement, reducing settlement. And under structural loads. So these are the things. So for this particular project, we are going to choose this dynamic compaction. In this, what are the mechanics of dynamic compaction? What is the process involved in this dynamic compaction? A weight, whether it is typically steel or concrete weights ranging from 5 to 20 tons. It depends upon the range depends upon the desired property of the soil. Based on the soil conditions, we are consider this how much ton is required. Drop height usually between 10 to 30 meters. It is also depends upon the soil conditions, and based on the required load bearing capacity we are going to choose. We choose this drop height. So this energy per drop rate calculated the weight multiplied by the height. A 10 ton weight dropped from 20 meters delivers 200 ton meters of energy per drop. It depends upon the energy per drop. The impact of weight creates shock waves that rearrange soil particles into a denser configuration. So for understanding this denser configuration, how much it is changed after all the iterations done. So before and after we have to done this, we done the soil property tests. Soil properties are going to test, then we will understand before and after this action dynamic compaction technique is used, and after that what are the soil properties. We will understand. In this is the mechanism which is involved in this dynamic compaction. In the suitability of the soils for dynamic compaction, so loose granular such as sandy, gravels and fills. These limitations also less effective in coastal soils, clays, and very fine silts due to low permeability and poor damage is the limitations. So it is suitable, these dynamic compaction DC. DC, dynamic compaction, DC. It is ideal soils, loose granular soils such as sands, gravels and fills. Limitations, less effective in cohesive soils and very fine silts due to permeability and poor drainage. So in this application of dynamic compaction in the Yamuna Expressway, this site conditions, soil composition, challenges. The expressway site included loose fills, soft soils and verifying soil strata along its length. In this, include whenever the type of the soil, whether it is loose fills or soft soils. So based on the soil composition, it depends upon the type of soil. And these challenges differential settlement because of these Yamuna Expressway is very long. It is 165 kilometers throughout. So each have their own kind of soil types and soil conditions and soil properties. From where the starting to ending, it may not be same. It may 100%, it may not be same. So in this differential settlement is the one of the challenge which we are understand. The risk of uneven settlement due to varying soil properties. Because of the soil properties, various soil properties are involved in this. That means varying soil properties, it gives the risk of uneven settlement. And load bearing capacity, need to ensure that the soil could support heavy loads imposed by the road structure and the traffic. So this is the load bearing capacity. It's need to ensure that the soil could support the heavy loads imposed by the road structure and the traffic. In the implementation of this dynamic compaction, some of the preliminary investigations are required. Those are soil testing, trial compaction. In this extensive geotechnical investigation to determine the soil properties including density, moisture content and compressibility, we have to done these tests. So thus density, once we understand these properties, that is density, moisture content of that particular soil condition and the compressibility, according to that we are going to choose this range and how much drop height. So according to these properties, we are going to choose these things. So now once we choose these, determine all these properties, test sections are compacted to determine the appropriate weight, drop height and grid spacing. So based on this implementation, these are the preliminary investigations we have to require and we have to done for getting these appropriated weight, drop height and grid spacing. Now in this compaction grid, this grid pattern in this dynamic compaction was carried out into the grid plan typically with spacing of 4 to 6 meters. How much spacing is depends upon the getting the desired properties of the soil. In this passes, multiple passes were made with the weight dropped on each grid point several times. So in this monitoring, surface settlement measured to assess the effectiveness of compaction. In this, we are going to understand using this monitoring. So measured to assess the effectiveness of compaction, penetration test conducted before and after the compaction to evaluate the improvement of the soil density. For understanding the soil density and other parameters, we have to conduct the before and after tests. For understanding about the better understanding about the properties and the results, the soil improvement, increased density, significant increase in soil density, reducing the voids and improved load bearing capacity, reduced settlement, decrease in expected long-term settlement, ensuring the stability of the express highway, and this homogeneity, more uniform soil properties across the treated areas, reducing the risk of differential settlement. So these are the results what we get from these things. Now challenges and solutions in dynamic compaction. In challenges in environmental concerns, noise and vibration, dust generation. So in this we are dropping heavy weights from certain height. So it create noise and ground vibration could affect the nearby structures and communities. In the expressway, it may not be outside the area. Sometimes it may nearby the some buildings or roads, any other structures, it may nearby this particular expressway. So in that particular, where we are going to do the alignments. Once we done this alignment, throughout the alignment in any area, nearby structures are there, infrastructure or any communities are there, they are going to affect because of this dynamic compaction. It is one of the challenge which we are going to understand in this particular technique which we choose in environmental concern point of view. So here, once, for example, 8 ton, we are dropping from certain height, it creates so much of noise as well as the ground vibrations. So at that particular, this is the challenge which we are faced. And one more thing, we know this soil is very silt, very fine. So once we done this action, this dynamic compaction, certain height, we drop on heavy weight, it gives so much of dust because of the fineness of the soil. So these are the environmental concerns which we face in this using of this dynamic compaction. And soil variability, heterogeneous soil, groundwater. So variation in soil types along the expressway require careful adjustments of compaction parameters. Every time we may not be use same kind of, for example, one such stress we use, for example I am taking, so for example we choose 8 tons 12 meter heights. It may not be same throughout the expressway, it is going to vary. That soil variability is there. So that's why in some case we may choose 5 tons, only 10 meters height, maybe 10 tons from 30 meters height. These are the variations are there throughout the thing. So throughout once same kind of dynamic compaction we may not apply. The variations are there in sort of may height or heights or weights in any way. The grid, some may choose 4 meters, in some stretch it may choose 6 meters. These versatility is there. According to that, we have to understand. So this heterogeneous soil, variation in soil types along the expressway required careful adjustment of compaction factors, parameters. Now these high groundwater levels in some areas could reduce the effectiveness of dynamic compaction. So high groundwater, it sometimes the level of the water table is more. How much we done this dynamic compaction, it is made very less effective. The effectiveness, what it is not how much we expected. We didn't reach expected outcome. So that is also one more challenge which we are going to understand in soil variability. In environmental concern, these are the challenges. In soil variability, those are the challenges. And structural consideration, adjacent structures, utility lines. So protecting nearby buildings and infrastructure from these effects of vibration and ensuring that underground utilities were not damaged during the compaction. So some underground works are happening, some pipelines, drainage work, something. Because of the stretch is more, 165 kilometers. In between any underground works, any kind of tunneling, something it is there, it is not going to affect. These are the structural consideration challenges which we understand in this particular using of the dynamic compaction as a technique. Noise and vibration, dust generation, heterogeneous soils, groundwater, and also the adjacent structures and utility lines. So these are the things which we are going to face. So what are the implementations for this using of these technique? These many challenges we are going to undergo. So what kind of solutions are there for these challenges? So now we discussed those solutions here. Vibration monitoring. So continuous monitoring of vibration levels to ensure they remain within safe limit of for the surrounding structures. So the monitoring is very, very important. So once we understand the vibration, whether they are affecting the nearby structures or not, that monitoring is very, very important. That is the one of the solution which we are going to implement. And adjusting the compaction factors, modifying the weight, drop height and grid spacing based on the site specific conditions. So for getting the same compaction throughout the, not possible. So it depends. So we will get, finally we want 6. 2 to 3 is equal to 6. 3 to 2 is equal to also 6. For some other example, maybe we consider 24. So multiple of two numbers. I want 24. Multiple of two numbers. It is 2 into 12. It is 2 into 12 is equal to 24. And also 8 3s are 24. And also 4 into 6 is also 24. So like that we are going to understand. So 2 into 12 gives the result, the same result. 3 8s are same result. 6 4s are same results. But what we have to understand, the compaction should be same whether the soil conditions are different. We are going to adjust like this. In one particular stretch demands 8 tons, 4 meters of the grid space and 10 meters, 12 meters height. That gives the X1 compaction. Similarly, in other condition, in other stretch, 10 tons, 6 meters, 15 meters, 10 tons, 6 meters of grid may give the X1 compaction. Like that, we have to maintain the uniformity of the compaction, though adjusting the compaction factor, modifying the weight, drop height and grid spacing based on the site specific condition. So according to that, we are going to adjusting the compaction factors. In dust control, implementing the dust separation measures such as water spraying. So whenever we are getting huge water means we used to spray water, reducing the, we are controlling the dust. This is also one of the measure which we follow. And pre-treatment in sensitive areas. In areas with high groundwater, pre-treatment methods like dewatering were employed to enhance the compaction effect. So this dewatering technique is another kind of ground improvement technique which we are used as a pre-treatment in high groundwater areas. That pre-treatment methods, dewatering is the traditional groundwatering technique to enhance the compaction is the effective. These are the solutions. So based on the various challenges, so what kind of project it is, what kind of method we choose technique, and in that what are the conditions, what are the there, what kind of challenges we are going to face, what are the solutions we are going to implement. Now this comparative analysis on based on these challenges and solution, this dynamic compaction and other ground improvement technique. Dynamic compaction versus other ground improvement techniques. Cost effective. Dynamic compaction is generally more cost effective for large open areas with suitable soil condition compared to the other like deep soil mixing and stone columns. Why? Because it requires heavy weight. We are dropping that particular machinery for large and open areas with suitable soil condition. Compared to the soil mixing, we have to choose material for soil mixing, and we have to use equipment for that also, and involve installation process is there. So these are all involved in this particular other different ground improvement techniques. So that's why it is cost effective for large and open areas with suitable soil condition. Speed of construction. This dynamic compaction rapidly implement, making it suitable for projects with the tight schedule. They require design consideration, installation process. After that also it took some time. These are all involved in various other ground improvement techniques. The mixing process, design considerations. After that we are going to remove that particular thing. These are all the parameters involved in other ground improvement techniques. Here it is rapidly implemented, making it suitable for projects with tight schedules. Less effective, but here also some limitations for this dynamic compaction. Those are less effective in coastal soils, requiring alternative or supplementary methods. These are the limitations. Less effective in coastal soils, requiring alternative or supplementary methods. In this case study on compressions, other highways in India, compare the use of the dynamic compaction on the Yamuna Expressway with other projects like Mumbai-Pune Express or Delhi-Gurgaon Express, where different ground improvement techniques were used due to the varying soil conditions. It depends upon the soil conditions for choose the technique. So here the Yamuna Express have their own kind of soil condition when compared to the other expressways. That's why we choose this dynamic compaction technique in this particular expressway. And long-term performance and monitoring, here the post-construction monitoring, settlement monitoring, payment performance are involved in this long-term performance and monitoring. What are the various maintenance considerations are involved? We will see in this particular slide. Here, post-construction monitoring. So, settlement monitoring, regular monitoring of settlement over time to ensure the effectiveness of the dynamic compaction. So, regular monitoring of settlement over time to ensure the effectiveness of dynamic compaction. Pavement performance, evaluating the performance of pavement structure including any signs of distress or failure. So, in this regular monitoring of settlement over time to ensure the effectiveness of dynamic compaction, in this pavement performance, evaluating the performance of the pavement structure including any signs of distress, failure. In this maintenance considerations, routine inspections, repair strategies. So, regular inspections and maintenance to address any potential issues arising from residual settlement. For understanding this residual settlement, we have to choose this. In repair strategies, approaches for addressing any localized settlements or pavement distress that may occur over the time. And in environmental and social impacts, environmental impact assessment, once we consider these environmental impact assessment and social impact, in environmental impact assessment findings, discuss the findings of environmental impact assessment conducted for the project focusing on the environmental impact of dynamic compaction. DC is nothing but dynamic compaction. These mitigation measures to minimize the environmental impact such as noise reduction strategies and dust control. So here we are going to choose the noise reduction strategies, and we use some peak periods, and we choose like that, and dust control, water spraying. These are the mitigation measures we choose for this environmental impact assessment. In social impact, community engagement, efforts made to engage with and address the concerns of local communities affected by the project. So, these community engagement, we have to understand the concerns of the local communities. So, in these communities, we have to understand and how that is affected. So, at short term, it may affected like that whenever the scenario is like that, but long run, how it is helpful. These are the things we have to understand. And also the compensation and relocation policies for compensating affecting individuals and relocating those in pathway of the expressway. These are the social impacts. And in this conclusions, what we understand, effectiveness of this dynamic compaction proven to be an effective method for improving soil condition along the Yamuna Expressway. In these challenges, various challenges were successively managed through careful planning, monitoring, adoption of techniques. In this, importance of site-specific investigation, monitoring and community engagement in large infrastructure projects. In future consideration, advancements in dynamic compaction, potential advancements in equipment and techniques that could enhance the effectiveness of dynamic project in future projects. In this, sustainability considerations for making dynamic compaction and other ground improvement techniques more environmentally sustainable. So why, when we are discussing these environmental parameters for Yamuna Express case study, particularly in relation due to these dynamic compaction, it is important to consider several parameters that influence the local ecosystem, human health and sustainability. So below are the some of the key environmental parameters to be considered. The one is noise pollution. In this, the impact of heavy weights dropping during the dynamic compaction process generate significant noise. In this impacts human health and wildlife. In human health, prolonged exposure to high noise levels can cause hearing loss, stress, and sleep disturbances for nearby residents. These are the human health issues, these are the impacts we will get from this noise pollution because of this dynamic compaction technique we choose for this Yamuna Expressway. In coming to the not only human life, wildlife nearby, any kind of forest, any kind of other wildlife, noise can disturb local wildlife, particularly birds and other animals sensitive to sound. And in this mitigation schedule, limiting dynamic activities to dynamite hours to minimize disturbances, and also provide sound barriers, installing temporary noise barriers around the site to reduce the spread of noise. So we have to provide noise barriers to reduce the spread of the noise, and monitoring, regular noise level monitoring to ensure compliance with local regulations. In vibration effects, because of this vibration effect, the source, the dropping of heavy weights induces ground vibration that can be propagated through the soil. This impacts structural damage, underground utilities. In this, vibration may affect nearby buildings, potentially causing structural damage, particularly to older or weaker structures. In underground utilities, vibrations could disrupt underground utilities like water pipes, sewer lines and cables. These are the impacts which we are going to understand from this vibration effects. And mitigation. In this vibration monitoring, continuous monitoring of vibration levels to ensure they remain within the safe limit for structurals and utilities. Buffer zones. Establishing the buffer zones where no dynamic compaction is conducted nearby sensitive structures. We are going to not using these kind of dynamic compaction. For this kind of buffer zones, we have to provide, then only this is the one of the remedy for any sensitive structures are there. Reduced energy drops, using lower drop heights or weights in sensitive areas to reduce this vibration intensity. And it is not possible in some of the ways. This is the only technique we have to choose, means we have to reduce the drop heights and weights. So that may less effective in this sensitive structures. So like that we have to understand this dynamic compaction. And dust and air quality point of view, the amount of weight on the soil can generate dust, especially in dry conditions that affect the air quality and visibility. Those dust particles can contribute to air pollution, affecting the respiratory health of the work and also nearby residents also. This visibility dust can be reduced the visibility on nearby road. It is also one of the affect the safety, that posing a safety risk. In this mitigation, dust suppression, air quality monitoring, personal protective equipment are used. Regular watering of the site to suppress dust generation. Implementing air quality monitoring to track dust levels and take corrective actions if necessary. Providing PPE such as masks to workers to protect against this dust inhalation. And this soil contamination, Potential for soil contaminations, that is the way, that is the source is to be released to soil during the dynamic compaction, especially if the site include industrial waste or polluted fill materials. This impacts groundwater pollution. Contaminants could lead into the groundwater affected water quality. And also soil quality, long-term soil degradation could occur if contaminants are not managed properly. These are the things which we are going to understand in this soil contamination. Till now, because of these dynamic compaction, noise pollution, so human health it affects, any wildlife and all, and structural damage nearby, and your underground utilization, and also the air quality and visibility, groundwater pollution, soil quality are the things till now we understand. For these, reducing these effects, conducting through site assessment to identify and remove any contaminated materials before dynamic compaction. Using containment strategies such as geotextiles to prevent the spread of contaminants during compaction. Monitoring regular testing of soil and groundwater quality before, during, after dynamic compaction to detect any contamination. And this groundwater impact, because of the dynamic compaction, can potentially alter the permeability of the soil, affecting the movement and quality of groundwater. It impacts aquifer recharge, water table fluctuations. In this aquifer recharge, changes in soil structure could affect the recharge rate of local aquifers. And also the compaction could cause fluctuations in the local water table, potentially impacting nearby wells or agriculture activities. In mitigation, hydrological studies, controlled compaction, monitoring wells, conducting studies to understand the impact of dynamic compaction. DC is nothing but dynamic compaction on local groundwater system. Controlled compaction, adjusting compaction intensity in areas with high groundwater levels to minimize impact. Monitoring wells, installing and monitoring wells to track groundwater levels and quality during and after the project. These are the groundwater impacts and their suggestions for getting the for reducing these effects for in groundwater point of view. And this vegetation and land use, the construction and dynamic process and the dynamic compaction technique process may involve clearing vegetation and altering the land surface. Because any kind of vegetation, plants, anything are there, by using this land we have to remove all these things. So it impacts this habitat loss and erosion also. Clearing vegetation can lead to the habitat loss for local flora and also this causes this erosion. Disturbed soils can be more prone to the erosion, particularly if vegetation is removed. So it may cause the soil erosion also. In this, the remedies are minimizing the land disturbance, revegetation, erosion control. So limiting the extent of land clearing to what is necessary of the project. So we have to limit it and minimizing the land disturbances as how much we can. In revegetation, implementing a revegetation plan to restore disturbed areas after construction. In this erosion control, using erosion control measures such as slit fences and mulching to prevent soil loss during and after construction. So these are the things which are involved in this vegetation and land use. These are the impacts and also the remedy measures for using this kind of dynamic compaction technique for construction project. Any kind of construction, especially in this Yamuna Expressway, we are talking about as a case study. Water management and runoff. In compaction and can affect surface runoff parameters, potentially leading to increased erosion or flooding in nearby areas. These impact flood risk, water quality. In flood risk, altered runoff parameters could increase the risk of localized flooding. Water quality, increased sediment in runoff can affect water quality in nearby rivers, lakes, or wetlands. In mitigation, drainage planning, design effective drainage system to manage runoff and minimize flood risks. That is important in water management and runoff. In sediment control, implementing sediment control measures such as retention ponds or silt barriers to protect water bodies. Post-construction management, ongoing monitoring of runoff and water quality to detect and address any issue that arise. These are all comes under in water management and runoff. In these are the effects we will get, and they may reduce the effects using these risk measurements and reducing measurements. And impact on local communities. The construction activities including dynamic compaction technique we choose for construction work, it impacts the local communities. How they impact? It can impact nearby communities in various ways. Those are health and safety. Because of this noise, dust, vibration can affect the health and well-being of the local residents. And also livelihood disturb. Because of this construction activity, it might disturb local businesses or agriculture activities as well. These effects are there. These are all considered, these are all in environmental concern. For these remedies, community engagement, compensation and support, health and safety measurements are helpful for getting the reduce the effects by these using these kind of ground improvement techniques. Such type is dynamic compaction. In community engagement, engaging with the local community to inform them about the project and address their concerns. So we have to address. All of a sudden we'll go and we'll do all these kind of vibrations and all these kind of techniques which we are using, heavy equipment in that area, excavations, we will deep excavation we will done. So it may disturb. So each area has their own kind of different cultures, different kind of activities, different kind of routines they are doing. So at that time we have to engage with local communities to inform them about the project and address their concerns. Then they will arrange any kind of arrangements, other alternatives they will search. There is a chance for getting better management and community between the construction people as well as the local people, and they mutually together support the construction work. So that community engagement is very, very important. In compensation and support, providing compensation or support to those who are affected by these construction activities. It helps mutually, it helps for both these sides. In health and safety measurements, implementing health and safety measures to protect both workers and local residents also. Because all these noise, dust, these workers are also faced. How much PPE is there? Any equipment is there for safety equipments? Even though the workers are going to affect, for reducing that effect, we have to measure. More safety measures is required. And implementing the safety measures is helpful for the local areas also. In regularity, compliance and environmental impact assessment. Legal framework, compliance with national and local environmental regulation, including those related to the noise, air quality, water management and land use. And environmental impact assessment would have been conducted before the project began to assess potential environmental impacts and outline mitigation strategies. In this environmental impact assessment recommendation, monitoring and reporting, adaptive management. In monitoring and report, regular monitoring and reporting on environmental parameters to ensure compliance with the environmental impact assessment. And adaptive management, adjusting construction practices based on the monitoring results to minimize the environmental impacts. These we have to follow the legal framework. what kind of compensations we have to give for these local areas affected, and how we have to maintain the air quality. We are not going to disturb any kind of land use and noise and air quality, and within the permissible limit, within the accessible limits only, we have to conduct any kind of, we have to adopt any kind of technology. These are all in these regulatory committees they are going to decide. We have to, within the legal framework only, we have to conduct all the activities. So understanding all these and managing the environmental parameters associated with dynamic compaction on the Enviro Express is crucial for minimizing the project's effect on the local environmental and communities. By implementing these comprehensive various strategies and ongoing monitoring and community engagement, the project can achieve its goals while maintaining environmental sustainability. Like this, we are going to understand these kind of case study. We will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.